Well, hello everyone. Welcome back to Adrian's Digital Basement 2. So today we're going to be looking at this video card here. This is an IBM CGA card that was found in a pile of scrap. And well, we'll look at it in a second, but it's really corroded. So it was basically left for dead. I want to try to recover this thing, see if I can make this thing work again. Now, before we get started, I just want to announce two quick things. I'm going to be at VCF Southwest in Dallas. That's in June of 2024. And I'm going to be at VCF Midwest in Chicago, and that's in September. I'll put links in the description below to the times and the dates and stuff like that. So if you're thinking of going to either of those shows, I'll be there. So I'll see you there. So let's take a look at this card and see if I can make this thing work again. So what we see here is an IBM CGA card. So the original card that was first released with the IBM PC in 1981. There are actually two revisions of this card. I'm not sure which is which. Let's take a look at the dates on here. This is 1982, so that is quite early. This Motorola chip, 1982, 38th week. And this one here, 50th week of 1982. So this is definitely the latest date. So this card seems to be from the end of 1982, 31st week there, 10th week, 25th week for RAM here, 31st week for this ROM chip. But the fact is there's another 50th week date that kind of tells us when this card was made. So I'm going to guess that this is probably one of the earlier cards, since this was made pretty much less than a year after the IBM PC was first released. Now, I don't think I need to talk too much about the specifics of the CGA card. It has digital TTL RGB output. It can display 16 colors of text, but only 4 colors of graphics. It has 16 kilobytes of DRAM used as video memory. It has a 6845 CRT-C, so it's a CRT controller. There's a ROM chip right here that holds the character ROM that is displayed serially through the video output connector. The actual code that initializes and controls the card itself is not contained on a ROM chip on the card. It is in the ROM BIOS on the motherboard. It also has a composite video output that can output a monochrome or a color video signal, and the color video signal also supports artifact color. So while it only supports 4 color graphics through the digital RGB, it can actually display 16 color graphics through the composite video, and that's artifact color, much more like the Apple II uses. Now, when it comes to the corrosion and the damage that's on this board, it's kind of obvious what happened here. This was obviously installed into a computer that had a clock card of some kind, and what happens is the clock battery starts to leak, well, and then it gets down onto the motherboard, and I didn't get the motherboard, it wasn't given to me, but we can assume the motherboard had a massive amount of corrosion on it, and this card unfortunately suffered pretty badly. Lots and lots of corrosion here on the gold pins. We have some solder mask missing there, but then there's also this weird black gunk on a whole bunch of these chips here. I also noticed that there is corrosion there and also along the edge of the slot connector there. Slot connector doesn't matter. This probably doesn't really matter too much, but this stuff on all these ICs, not great. Now, luckily, all the ICs that are on here are pretty run-of-the-mill and they're off-the-shelf parts. So if any of these did go bad, theoretically, we could try to replace them. But obviously the very first thing we need to do is try to deal with this corrosion right here. And this might be quite a bit of a problem, because if we find that when we remove this corrosion that the gold contacts are pretty much non-existent, it's not really easy to actually rebuild those. You can try putting some foil down, but it'll get scraped off when you stick it into slot connectors. And honestly, if this is really damaged beyond repair and we can't make this work again, then this card unfortunately is a goner and it will just be spare parts. So this video may not have a good outcome. I'm recording this video not knowing what's going to happen with this board. And of course I haven't tried it in anything because I don't want to stick this into a motherboard, not the way it looks here. Now on the back side, things aren't looking so bad. It's not great, but it's not as bad. There's not all that green crusty stuff here at least. It just still looks pretty rough. The rest of the board here seems to be lacking in any kind of corrosion altogether, so that's a good sign. We'll just take a look here. What's this all about? Who put that there? That was not me. That's funny. These are little stickers, obviously, and they point to those 2 pins for some reason. And these are DRAM chips, and I wonder if someone was trying to indicate that there's some kind of a bit problem on those 2 RAM chips. I don't think any rework has ever been done on this board, not with these RAM chips. That looks all perfect there, so don't know what that's all about. Rest of the board, though, looks good. Typical IBM construction. I think it's a multi-layer board, meaning I think there's a ground plane on the inside there, which makes it extra hard to desolder stuff. Rest of this, though, yeah, looks pretty good. Okay, so first thing we need to do is we need to try to attack this corrosion that's right here. Now, you could try to use vinegar, but the issue is, especially with stuff like these pins here, those are raised off the board. It's not easy to use vinegar or citric acid or whatever to try to eat away stuff that's like off the board. You could submerge the entire card in that, but that would be a lot of material and kind of a waste. So over the years, people have recommended something to me, and I've actually had really good luck with this. And it's this stuff right here. It's Loctite Rust Dissolver, aka Naval Jelly. Now, I don't know why it's called Naval Jelly specifically. It's just a very strange name, right? From my understanding, this was used by the Navy, as that's why it's naval, the Navy, the US Navy, or maybe the Navy in another country, to help dissolve rust on ships. And when you look at it, it's actually like this bright pink jelly. And why I like this over the citric acid, for instance, or the vinegar, is that you can paint this onto stuff and it stays put. So apparently that was supposedly how this was used on ships, to like paint onto rusty areas. You let it sit and then you wash it off and it's attacked the corrosion and you can paint over it. As you can see here, it says dissolves rust from metal surfaces. It's made by Loctite, which is a US company. It's got English and Spanish on it. This is sold here in the US market. I'm completely unaware if you can buy this in other countries, but take a look at this. Naval Jelly is a registered trademark of Naval Jelly Company, LP. So maybe that's not even a US product. On the other panel, it says Naval Jelly Rust Dissolver is the original formula that's been trusted since 1966, used on steel, iron, and other ferrous materials. Do not use on aluminum, chrome, stainless steel, or painted surfaces. Will remove bluing from steel. Wipe off painted surfaces immediately. It will remove paint. Tips for success: remove loose rust and dirt prior to application. Does not provide long-term protection. If left on too long, it hardens. And apply more Naval Jelly to dissolve or remove. It's saying here to leave it on for 5 to 10 minutes. I mean, we're using it in an unapproved method here on a card, but I've done this before and it seems to work quite well, and it works quite fast. It's pretty powerful stuff, and you really do need to wash it off when you're done. As far as what's in this, I don't really know. It doesn't say, unless I'm missing it here. It just says, yeah, chemicals known as stated California cause cancer. This is a ridiculous warning. That's literally on everything. In fact, it's on coffee. I mean, it's not now because it was on coffee and then they passed an amendment to the law, Prop 65, to take it off coffee. But based on the way the law is written, it actually counts coffee as something that should have this warning. It's completely silly. Anyhow, yeah, so this stuff is pretty cool. It's bright pink. It's jelly-like. And I'm gonna paint it onto here and we'll let it sit and we'll hopefully get rid of this crusty corrosion here, and then we can deal with cleaning up the card and seeing if it works. So what I'm gonna do is I'm just literally gonna dump this on, and I'm gonna spread this around with this cotton bud here, and I'm gonna put it on the chips here as well where that brown gunk is. Okay, and I guess we'll just let this sit for a while, see what happens. Now, let me just get a little pointer. You can see it's foaming up a little bit right here. So that's some of the corrosion being eaten away by the Naval Jelly. And look, also right here on those nuts, they're also being eaten away. Let me get a little stick or something well, I guess I could just use this. It's plastic, so it's fine. I want to make sure that it gets the corrosion off these pins here. Already it's having an effect here on this stuff. This looks a lot better. I mean, that was quick. That's amazing, actually. It works very quickly. You really don't want to leave this on too long. It says it's eating paint, but I don't know. It seems to be okay. Anyways, there was a lot of that black gunk all around the chips up here too. So this board might be a goner, but I figured I might as well try. And that's what this video is really about. I'm just poking, and that's what I like about this stuff, is it just stays put. Unlike if we put vinegar on this, it would have run all around the board already. This, on the other hand, it's just doing its thing without any complaints. I'm just gonna add a little bit more, so we have a nice thick coating everywhere. Stuff's pretty cheap. I don't remember how much I paid for this container, but I've had it for a while, so doesn't really matter. I'm near the end of it because I've used it quite a bit on all sorts of things. Like, the nice thing about it as well is if you have, say, a motherboard that has slots, well, getting the vinegar into those, it's hard to just pour it in, it just runs away. But you put this stuff in there, and it's so thick, it just sits in there, and you have no issues. So that's what I love about it. So if you were a viewer that recommended this stuff in the past, thank you very much. And if you live in a country where you can't get this, apologies for talking about it, because it's just, like I said, it's really cool. I'm gonna pour more on this connector here. Now, one of the things I found that's helpful is, like, use an old crap toothbrush, and you can really give it a good rub into things. One thing I'm going to do is I'm just going to give this a little bit. Oh, it's already on the back anyway, so I'm just going to make sure there's a bit on here in case any corrosion has made its way through. It's doing its thing. And of course, I don't care that this cutting board gets some on there. It's completely fine. All right, I'm just gonna let this sit, and I'm gonna leave it on here for, I don't know, 5 more minutes. I'll set my timer, and then I'll be back. All right, it's been 5 minutes. Stop. There we go. Let's see how this thing looks. I mean, is that not incredible on the bottom here? All that green crusty stuff, it's kind of gone. Now, I think what's happening is there might be some copper that's exposed here, so we're not gonna leave that on there for too much longer, but it looks pretty good. Pretty good. Look at the green there too. It's just gone. Do I need to leave this longer? Maybe I do. Let's see how things look, because there was a bunch of green crusty up there on those pins. I didn't really talk about that. It still looks pretty rough. That doesn't really matter, to be honest. I mean, the only thing that really mattered was, to be honest, this part here. And I guess what was on the chips, because I didn't want it to keep getting worse. And I'm going to say all that black stuff that was on there, that kind of crusty, I mean, it was weird. It was green crusty, but it wasn't green, it was black. That stuff seems to be gone. Let's flip this over. Look at the other side here. I mean, that didn't look so bad anyways. It pretty much looks the same. So, okay. Yeah. Stuff's amazing, as usual. I really wanted to get this edge connector looking good so we could stick that into a slot on a computer, and well, I'm gonna say that this thing is pretty much ready to go. I'm just looking for any additional foaming. It kind of foams up as the reaction is happening, and it's doing it right there on those nuts. That looks good. I'm just gonna grab some of this paper towel here, and I'm gonna wipe this part off. That's frankly staggering how much better that looks. Really is. I mean, if anything, the back looks worse. There's like some of those pins that really are quite eaten away. You can see as I wiped the gold contacts there, kind of, I don't know if that was gold that was coming off or corrosion or what. Well, I think I'm gonna call it, and I'm gonna take this upstairs to the kitchen sink, and I'm gonna give this a really good scrub. Both soap, water, kind of soak this. You really got to get all of this stuff off there, because I think it will keep eating away if you leave any of it behind. All right, there's the card after washing, and well, let's just say there's a massive improvement. It's absolutely stunning how it looks. Now, the reason why those look a little darker is the plating has actually been eaten away, and that's the copper that we're looking at there. So there's exposed copper, and the problem is I'm assuming exposed copper is going to corrode. I mean, it's conductive, so we can test this card right now. But can you absolutely believe how this top connector looks now? You'd almost think it's a different card. There's maybe a tiny little bit of corrosion on there, just like the ever smallest amount. I'll probably scrape that away with a pick or something. Let's see if I can get rid of that. Yeah, there we go. That looks better now. Now I think there's a little bit of copper exposed here as well. See how it's a different color? It's gold there, copper there. So I just need to paint that with a little nail polish or something just to cover that up. This is all looking a lot better as well. I mean, look at these. These were all rusty and now they're not. And then all that black gunk is gone too. But you look at that. Little bits of copper is exposed here. So clearly that was corrosion, even though it was sort of a black color for whatever reason. But you see that? Copper there, copper there. So it was eating away at the legs of those ICs. These pins also kind of have exposed copper now. Of course, that's not a big deal. We can just easily replace those. I mean, the biggest problem is this thing. You can't not replace this very easily. I am absolutely shocked how good this came out. Let's look at the backside. All right, sort of similar. It's also looking really good. I mean, this is all going to be conductive. I don't think there's going to be any issues. And what I can do is I can just tin these. This is just copper here. I can just tin this stuff. It should be fine to tin now. So those three, those two over there, maybe this stuff here. And then on this side, those two, maybe just the ends of those. But as it is, we can certainly test this board as in a motherboard now. And let's see if this thing that was basically scrap works now. Let's see. We're gonna test it in the old XT motherboard, the one that well, this is not the one I've had so much trouble with. This is the working one that is like the one I had so much trouble with. I've been using this board quite a bit lately. It's gotten a lot of use. But we'll plug this CGA card into here. We'll see what happens. Before I put this into the motherboard, I'm just gonna put some Deoxit on there. Oh, that flowed quite quickly. That bottle, I recently refilled my little dropper bottle here. And when it's full, the Deoxit just sort of loves to pour out. The reason why I'm putting this on is Deoxit has a little bit of an oil coating on it, so it should actually help prevent the corrosion from happening really quickly. I don't really know how quickly copper oxidizes. Oh, that doesn't look very good down there, does it? Yeah, that doesn't look great, but we'll see what happens. Maybe it works. Anyhow, I think it should stop the copper from oxidizing. I don't know. Probably wouldn't. It probably does nothing, but let's just see what happens. That's actually kind of funny. The shape of this board has this cutout here. It actually hits these ROM chips here. So you kind of have to stick it over here. And look at that, even there, it doesn't really go in all the way because it hits the RAM chips. How silly is that? What about in this slot way over on the edge here? It's kind of up against those chips and stuff there because they're in sockets. Oh well, kind of weird, but that should not cause a problem. There's nothing conductive on the lower edge of the board there. I'm just going to drip a little bit of Deoxit into the DB9 or DE9 socket. Sorry, it's a DE9, not DB9. All right, so this cable here goes to the RGB to HDMI. This thing is connected to power. Power supply is connected. I don't have the keyboard connected yet. Let's just see what happens. Okay, here we are. We're on the RGB to HDMI. So let's just make sure before I turn this on. Yes, okay, looks good. Here we go. Oh, it just worked. It just works. Wow, I don't know. I saw a black screen. I was like, oh, it's probably dead. I'm shocked, but not really, because, you know, field found 64, field found Amiga. These computers are so freaking reliable. And that thing had so much green, crusty corrosion on it, and it just works. Let me grab a keyboard and something to boot this computer with, and we can actually like put some graphics modes and check the RAM and stuff like that. All right, keyboard and PicoMem are connected up. PicoMem will allow us to just boot right up. Oh, look at that. Sweet. So hit the space bar. Oh no, you can't escape the RAM test. Not with this BIOS, or at least not the way this BIOS is configured here. I can't believe it. I mean, I believe it, but I can't believe it. It is, oh, I hit the space bar. That's my fault. The card, I really, really didn't think this card was savable. Let's just check the setup really quick here. I don't really need EMS. We could turn that off. I don't need any extra RAM. We already have 640 and CF card. Okay, we're looking good. So let's reboot again. All right, if we run check it, it has a little diagnostic RAM test, a pretty simple junk one, to be honest, for the 16K that's on the CGA card. So we'll just quickly go through and do that. If we go down to test video, all tests, this should run through all the possible tests. Okay, here's the RAM test. So far, so good. Yep, 16K RAM passed. So those little stickers that were on the back of the board pointing to 2 pins on the RAM, RAM chips. Don't know what those are doing there, but they were. CGA, this type of card has 3 text pages. Well, that's what we're looking at here. I don't know what check it does actually for testing this RAM. I mean, that RAM test it did, it was like random bytes or bits or whatever. I have a feeling it was a very rudimentary test, so not the best thing in the world. All right, so 40 column text mode. Excellent, looks good. 40 column text mode. I'm not sure the difference between those 2 modes. 80 column text mode, monochrome. 80 column text mode in color, looks good. This is like monochrome style with the underline, or no underline, just reverse and blinking and whatever. And the same thing in color. And there we go in 80 columns in color. And we have all the colors, and boy, that looks absolutely perfect. So all of the output lines are working flawlessly. That's RGB plus the intensity. And of course we have the 2 sync signals as well. And here we are, these are the graphics modes. And they just look good. They just look good as well. And there's our color palette. And it just works. This card is fully functional. Okay, that is not the card. That is the, I don't know, my capture setup because we lost the RGB to HDMI. 1 second here. Technical difficulties. Insert, test pattern thing, something or other. There we go. Okay, it's back. Yeah, that was not the CGA card. That was whatever. My capture setup does that sometimes. Okay, what can we do here to see if this card works? Now, one thing is, the flashing is normal. That is what happens on a stock CGA card. Somehow, my VTech card is modified in a way that does not do that flashing. And that is a BIOS routine to prevent snow. Otherwise, we'd see snow. It'd be cool if we could figure out what mod you could do on this card to remove that flashing. I know the flashing is, the way IBM designed it, and some people like it. But frankly, later CGA cards did away with the flashing because, honestly, that's kind of unsightly. Now here we are in Jim Leonard's CGA Compatibility suite, and we can do a few things in here. I mean, to be honest, we've already gone through the tests and everything seems to be fine. Let's look at horizontal retrace as an example. So this should show nice smooth bars, raster bars. Yep, working perfectly. I mean, of course it is. This stuff, yeah, anyways. Row reprogramming should show 16 color kind of pseudo high resolution modes here. The snow, did you see the snow there? So that is one thing that is different between this card and, for instance, the VTech card. The way it accesses the video memory is done in a way where the CPU can update the memory or read and write from the memory, and it doesn't cause that snow. The snow is happening because the way the screen is refreshing the RAM, the snow happens on the CGA card because it refreshes the screen, reading that DRAM that's on the card, this memory right here, and it doesn't, lock it. So the CPU goes to read or write from it, and it does it while it's in the middle of actually refreshing the screen, and that causes that snow. So I'm assuming they did something on the later cards to prevent that, or maybe it makes the CPU wait. That prevents that snow, but maybe it actually slows things down. I think there's a snow test in here somewhere. Here it is, CGA snow. So there he is. Look at that. If the adapter suffers from CGA snow, you should be seeing random noise below this message. Kind of a cool picture, or a cool image, to be honest. I like how it starts out with one line and it gets more and more and more. So whatever Jim's doing is obviously very targeted to show off the snow here. Now, incidentally, you notice how the snow is only happening every other character? In 40 columns mode, there is no snow. And in graphics mode, there's no snow. So you don't have any of those limitations. It is strictly an 80 column issue. Now, with the modification I was talking about, we cannot fix the fact that there's snow. That's like an architectural design of the card. What we can fix is the flashing to take it away, which will result in snow. We will have additional snow, but I think I would rather have a little bit of static on screen during scrolling in DOS than having it flash the way it does. I feel that that's really unsightly. Now, other systems that do the flashing when it scrolls, the original Commodore PET was the same. But the TRS-80 Model 1 doesn't, but it does exhibit some snow when it scrolls, all for the same reasons as this card does. I'm just looking at that pattern. It's quite pretty, actually. It really is pretty. It's nice. I like it a lot. Now I'm just going through some of the RAM speed things here. And of course, this is a 4.77 megahertz machine. It's a clone of the PCXT. It should be running at exactly the same speed as a regular XT. And of course, with this CGA card, this should run all those old demos perfectly. Oh, you know what? I just had a thought that I have this program on here. I think it's here, the Fast. There we go. Might cause snow on a color monitor. All right, well, there is a little bit of snow, but we still have flashing. And what the Fast does is it speeds up the BIOS routines, but I guess you end up in some flashing. Anyhow, what I wanted to do is run Area5150. Now, we don't have a speaker hooked up. I guess I should hook a speaker up. And we run this demo that is freaking awesome. And to be honest with this combo right here, it should work, I think. I mean, I don't know. Maybe the problem is going to be this Pico mem. Not sure what it's doing here. It might affect things a little bit, but we'll find out shortly. Okay, so far so good. So this really, yeah, there's a bit of noise here. This really pushes the limit of the 5150 or 5160 and this card right here. It does a lot of trickery on the CRT controller. So here we are, like, this is what we're expecting. I'll unplug the speaker here. Okay, yeah, same lines, graphics. Okay, anyways. 16 colors, yeah, this is, like I said, this is pushing the limit of what CGA can do. Normally you can't do 16 colors at 320 by 200. That's just not possible, right? But somehow it's doing it. Look, 640 by 200, what? You know, when this demo first played, it was like somewhere in Europe, oh, look, get rid of the borders. When this, look at that. Freaking look at that. From this old slow computer and this broken down old CGA card. When this demo first went live, oh, that's okay. I thought that was a crash or something. Yeah, CRTC. So that's this chip here. It's a Motorola CRTC. I keep trying to say, when this demo went live, I wasn't watching live, but I watched like a replay of the live coverage. It was a demo competition and, you know, Amiga demos, 64 demos, all that kind of stuff. And then when this, I mean, I can't believe that graphics right there, that's coming from a stock CGA card. Now there is like extreme trickery happening here, like cycle counting and just wild things to make this all work. And it doesn't run, as far as I'm aware, on anything but this combo here, 8088 and this video card. And that's because the clock speed has to be just right. Everything is doing all that cycle counting to change modes in the middle of scan lines and all that stuff. But it allows this kind of thing to happen. And, you know, on a machine that came out in 1981, this runs perfectly on it is frankly shocking. Yeah, even watching this, I've seen the videos of it, but I don't think I've actually seen this run on anything. But this is probably the ultimate stress test to see if your CGA card is actually working correctly. And of course, if you have an IBM CGA card like this, it's going to work perfectly. But if I use another CGA card, like a non-IBM card, it probably is an interesting test case to see if that card, oh, look, this is the graphic that used to be on CGA Compatibility Suite that Jim had there originally, and he took it out and replaced it with a different one. Nice. Anyhow, yeah, it's probably a good stress test to see if your CGA card is actually 100% compatible with the IBM CGA card when you run Area5150. But keep in mind, you got to run it on an original 4.77 megahertz clone or a real XT motherboard as well. I mean, look at that. Smooth freaking scrolling, 16 color high-res graphics. It's mind-blowing. I think it's using like text mode here. Maybe each scan line is one character or 2 or 3 characters or something like that. So it's using the built-in character set. Oh, that little glitch. That was not the card. That was my capture setup again. Anyhow, yeah, this demo is incredible. If you haven't seen it, I highly recommend you go check it out. I'll put a link in the description below to a video so you can just watch the whole thing. But and it does have full-on music. If I plug in the speaker, I mean, I wanted to talk, and this speaker is kind of loud. Let's plug this back in. You hear there's actual music. There we go. So yeah, there is music the whole time while this demo is running, which that is just wild, absolutely wild. Okay, so that pausing, by the way, that's funny. that was coming from it loading. I could see it loading off the Pico mem there. So I don't know if that happens on an XT IDE or not. The routines that Pico mem uses for disk access is quite different than XT IDE. So it could be when they developed this, they really had XT IDE in mind, because that's pretty much what everyone's always been using for hard drives and stuff. And now that the Pico mem is out, people are, you know, potentially switching to that. This just came out. Yeah, there was a video on the main channel recently about it. So this card, obviously, it just freaking works. So I think what I need to do is give it a little bit of TLC. And that means taking some nail polish, and I have some clear nail polish. Let me grab it. Here it is up here. Whoops, I'm dropping things. Yeah, I'm just gonna grab some of this, and I'm gonna paint it over all the legs that have a little bit of copper color on them, like right there and there. And that'll just help prevent any kind of future corrosion. As far as this goes, I don't know what I'm gonna do. I might just leave it with the Deoxit, and I'll see what that does. And the alternative is taking flux and tinning this stuff with solder. So we'll coat it up with solder, and that will obviously keep it from corroding. The issue is that that's not always a great idea, because I've heard that if you have tinned pins, or whatever these are called, little fingers, you put them in the slots, it can actually shed some of that material into the slot, and that maybe isn't the best thing in the world. Obviously I can't paint with this on there, because that needs to be conductive, since that's making contact with the slots. But for instance, on this, I can totally paint this part, because that doesn't matter. And in fact, we know there was some corrosion on these little nuts here, so that's probably lost some of the plating that was originally on there. So we can paint that on there. And you know, all this stuff here that had some corrosion on it, just paint it up. And you're kind of preserving, what is it, like the patina, I guess, that was originally there. And yeah, it's fine. I've used this clear nail polish before plenty of times on things, and it seems to be very, very long-lived. I'm just trying to look here to see where I actually need to paint, where the little bits of copper are showing through. No point to paint anywhere else, because that's just regular plating. Not to mention future diagnostics, it's going to be that much harder if I have this nail polish on there. Now, acetone would remove it, so it's not like you couldn't take it off after this has already been applied. Let's see, there should be some on this side as well, I think. A little bit right there. This stuff is very durable. If you think about this, people put it on their nails and then it wears off after a while, but that's with a lot of wear and tear. So it seems like when it's on circuit boards, I use it to cover traces and stuff. It seems to last a long time. Perhaps people will want to use that UV paint that they use to repair traces and stuff like that. But I've just stuck with this Dollar Tree, dollar store nail polish. And it's worked quite well for me. Oh, wow. There's a bunch of exposed copper over there. I don't remember having these ICs. Did I have the Naval Jelly over here? I don't quite remember that. And over on this, oh yeah, well, it's there too. You know what, that might just be oxidation of some other kind and not actually exposed copper. Not totally sure about that. But look, those are jelly bean parts, so it'd be very easy to replace those if need be in the future. How about this? So this slot connector here, just get this patina preserved by painting it. I'm just locking that rust in there. I mean, look, you know what? In a controlled environment down here in the basement, this is not going to be out in the elements or whatever. This thing is going to last forever. I don't think there's anything to worry about. And you know what? This sort of shows what this card has been through. So, yeah, that's been fun. I would love to hear your thoughts on what I should do down here. Will the Deoxit coating that's on there, let's zoom in a little bit more. Will the little oily Deoxit coating that's on here be enough to actually preserve this and keep it from getting worse? Or should I tin at least the copper legs here, like those two, the ones on the back, maybe the little ends right there? I don't know. You can see where the slot made contact with the card though, don't you? Right? It only went up to about halfway. That's interesting. Let's look at the back side here. Yeah, interesting. Yeah, this one looks pretty rough right there, doesn't it? That one there. Same over here. Yeah, put your comments down below. Let me know what you think I should do about those. I don't know, I'm torn. But I probably should tin those, shouldn't I? Just for safety. But look at that. It works. It freaking works. So that was a pretty fun little experiment for me. This thing was in such bad shape, honestly, and I kid you not, it was ready to be shredded. It was in a box of junk to go bye-bye, and I went, oh, maybe I can make this work again. And look at that. Naval Jelly freaking made this thing, well, made quick work of it, and it just works. I mean, testament to good quality electronics in 1982. That's what all the parts are from here. And even with corrosion on those ICs, just worked. I think now that we stopped that corrosion, there's no reason why this card will die anytime soon, except if this starts getting corroded again, like you get green oxidation. Even if there is green oxidation, you can clean that off with a little furniture, or not furniture polish, metal polish would clean off that oxidation, but then you really would need to tin these. The coating that's on here that makes it gold, the gold coating, you know, keeps that oxidation from happening. And now that it's been exposed, because I removed all that green crusty stuff, well, it could begin again. So maybe I could spray some WD-40? Maybe that would work. WD-40, you know, wouldn't make it not work in the slot connector, but I think the Deoxit, you know, should have a similar effect. I don't know. Yeah, so let me know your comments down below. Thanks for watching this fun video. It was really cool to get this thing working, and I'm really kind of glad to have saved it. I have a bunch of these cards, so it's not like I needed this card, but it still was nice to save something like this and look at a little bit of Area 5151 or Area 5150 in the process. Huge thanks to my patrons. Names are scrolling up the side of the screen over here. They make it possible to do this full time. If you want to become a supporter, there's a link in the description below. Don't forget I'm going to be at the VCFs coming up. Hit subscribe if you haven't already. Hit the thumbs up if you like this video. And yep, that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye.